Hello and welcome back. This is lesson 2 of a series Fundamentals of Material Balances. In this lesson, we will learn how one can apply material balance on a continuous process. First of all, we have to know type of balances. There are mainly two types. One is called differential balance, the other is called integral balance. So what is the difference between these two types of balances? So let's get started. Differential balances are usually applied on a continuous processes, and they tell us what is happening in the system at any instant of a time. More importantly, each term of a balance equation is a rate, like rate of input, rate of generation, rate of consumption. More specifically, we can say, for example, hydrogen gas produced per second, oil produced in barrels per day. So when you are specifying the amount with respect to time, then it is called differential balance. Now moving forward to the integral balance. Integral balances are usually applied on a on a batch processes, and they tell us what happened between two intervals of a time. For example, from start of a reaction to the end of the reaction. And in this case, each term of a balance equation is the amount. It is not dependent on a time. Okay, so this is the major difference between differential balance and integral balance. So in this particular lesson, we are going to learn how to apply differential balance. So here we are going to apply differential balance on a continuous distillation process. So this is the example: 1000 kilograms per hour of a mixture of benzene and toluene. So this is the important things: benzene and toluene containing 50% benzene by mass is separated by distillation into two fractions. Okay, the mass flow rate of a benzene in the top stream is 450 kg per hour, and that of toluene in the bottom stream is 475 kg per hour. The operation is at steady state. Write a balance on benzene and toluene to calculate the unknown component flow rates in the output stream. So this is the question or the problem we have to solve. So in material balance, whenever you have any problem, first of all, you have to draw a process flow diagram. It will definitely help you out to understand what is happening, and it makes much easier for you to apply correct balance equation. So this is, we can say, distillation unit. Okay, and here is the feed to this distillation unit, and I am saying it feed. And here we have benzene that I'm denoting or specifying with B, and a toluene that is with T. On the other hand, there are two outputs. One is the top product and the other one is called bottom product. So in the problem, it's given that benzene in the feed has a flow rate of 500 kg per hour, and they are saying it is in a 50% ratio. It means if it is 50%, so the total feed was 1000 kg per hour, so the other 500 kg per hour will be the toluene in the feed. Now moving to the top product, it's given that 450 kg per hour is the mass flow rate of benzene at the top stream, but we do not know the mass flow rate of toluene. So we have to find it out. Okay. In the bottom side, we have a flow rate of toluene, that is 475 kg per hour, but we do not have the flow rate of benzene, that is I'm saying MB, and we have to figure it out here. So mainly there are two unknowns we have to find, or we have to write the equation to have the values of flow rate of toluene at the top stream and the mass flow rate of benzene in the bottom stream. After specifying or making the process flow diagram or labeling all the streams, next step is we have to write mass balance equation, general mass balance equation, that is equal to input plus generation minus output minus consumption equal to accumulation. So remember, it says that the system is operating at steady state, so it means the accumulation is zero. Okay, it's a distillation process, there is no chemical reaction, it's just a separation, so the generation term will also be equal to zero, and the consumption, it will also be equal to zero, and the general mass balance equation will come out like input equal to output. So this is the now main mass balance equation that we are going to apply on this process. Moving forward, we have to apply this balance on on the components, like on the benzene and then on the toluene. So the input is the feed stream, where the flow rate of benzene was 500 kg per hour, and in output we have two stream, top stream and the bottom stream. So we know in the top stream it was given 450 kg per hour, but we don't know the in the bottom stream mass flow rate of a benzene. So if we solve this equation, it will come out 50 kg per hour. Okay, now let's apply a balance on toluene. Again, its input is equal to output, and what is the input flow rate for the toluene? It was also the same, 500 kg per hour, and in output, in the top, we have to figure it out, mass flow rate of toluene, whereas the mass flow rate of toluene on the other stream is given, that was 475 kg per hour. And if you solve this equation, so mass flow rate of toluene into the next stream will be 25 kg per hour. Okay, so to be sure, there is another balance we can apply on the system, and it's called total balance, total mass balance. And the total flow rate to the distillation tower was 1000 kg per hour, and from top and bottom it should also be If we combine them, it should also be 1000 kg per hour to close the mass balance. Okay, so let's take it 450 kg per hour of benzene plus 50 kg per hour also benzene plus 475 kg per hour toluene and 25 kg per hour toluene. So if we sum out all of them, it comes out 1000 kg per hour, that is equal to the input value. So we successfully solve this problem. In the next lesson, you will learn how you can apply integral balance on a batch process. I hope you like this video, and if you like this video, please don't forget to like, share and subscribe to the channel. Until next video, take care. Bye bye.